So, uh, Let us start with our today's podcast. So, I am your host, and today we are going to explore something very interesting. We will explore the intersection of RF design, VLSI, and India's growing semiconductor movement. So, please welcome Abhay Kulkarni. He is the founder of Bedrock Microwaves. It's a company it's a company working on microwave components right here in India. So he is also the group head of the Semiconductor Ecosystem Development Group. So it's a community initiative that is working to bring together academia, MSMEs, investors, and government to build India's own fab ecosystem. So, with experience spanning hands on device fabrication at Sense ISC, RF design roles, and now semiconductor ecosystem development, so he brings a rare blend of technical depth and visionary leadership. So, in this video, we will talk about how RF and semiconductors come together in real products, the challenges and opportunities in building a hardware startup in India, and how India can truly become a self reliant in chip design and manufacturing. Yes. So, let us start with your introduction.
Yes. Thank you, Anushka. Thank you for giving me this opportunity to talk about my experiences and my learnings. Okay, and I'm also in a learning stage all the time, so I'll also learn a lot here. So that is that. Okay, so let me start with a little while ago. As to how I got introduced to the RF field in to begin with. So uh, after my 12th, when I got admitted to BSc, I took an admission in BSc Electronics and in Ferguson College here in Pune, where I came to know about a club called Astronomy Club. And I think at that time there was a exhibition on Mars closest encounter, and I took part in it. And uh, fortunately, I got the part of handling the you know Pathfinder rover, and that's how I started learning. I started learning more about the Pathfinder, and then found out how is the communication and what all measurements it is doing there, right? So that kind of increased my curiosity about the communication, RF communication part, and then I also got to know more about radio astronomy, which is one of the important parts of the complete frequency spectrum for astronomy. So that's how the interest grew. And then later on, we did a lot of many projects. In fact, my BSc project was measuring Jupiter radio signals. And then we also did some other measurements at very low frequency for meteors and all that. So that's how my foundations also started becoming very stronger. And then eventually when I went to MSc, because I wanted to learn more about RF. So there we had different topics, different subjects on antennas and electromagnetics and things like that. So that's how it interest grew, and I wanted to learn more. So I was always in the research environment, and that's why I eventually further later on worked in different research institutes. For example, I worked in Giant Microwave Radio Telescope here. So there I learned how to build a low noise amplifier, because that is one of the very important electronics part in the front end. Then eventually later I went to Raman Research Institute in Bangalore. So there I went on learning on the same low noise amplifier at higher frequencies. And then I wanted to learn a little bit, so that's where RF interest kind of expanded, because I wanted to learn how are the transistors made. So I wanted to know, what's there in the transistor, because we are giving so much importance on the transistor, right? But we don't know what is inside the transistor. We need to know when we say noise figure of a transistor should be low. So what does it mean? right? So then I wanted to learn more. So there was an opportunity to learn in Center for Nanoscience and Engineering, ISC. So then that's where I thought, that's the best, place to be. So that's how this all the experiences were kind of linked to each other, and I tried to went deeper and deeper, and then there we learned, how transistors are made. Of course, that was a compound semiconductor, that was gallium nitride, but nonetheless, that was the moment where the whole semiconductor, uh, you know. Uh, thing was kind of exposed to me, and that was like a different world altogether. Right? So that's how I came about, and then later on, I wanted to, work on my own, have my own company, and that's why I started with Bedrock Microwaves in 2019 because I wanted to do something on my own. I like doing things, making new things, and that's how that interest grew. And then I wanted to, but then later on, I found out, okay, we need to run the company, so things have to be a little different. You cannot keep working, design. So that's how the building the company came into picture, and now it's running well. And now, as the semiconductor wave has come, so it is the right time to combine RF and semiconductor and use my experience to do something.
Yeah, that was very interesting journey. So, how do RF and semiconductors come together in real world products?
Right, right. So, so there are a lot of different ways to look at these RF and semiconductors actually. But if you kind of uh, look at them in a product, it goes kind of it's very counterintuitive. They kind of feed each other. So let us say there are different ways of looking at it. One is, there are RF concepts that are used in semiconductors, and in return there are a lot of different. I mean, of course, we know that semiconductors make a lot of different devices, that work in RF range. RF frequencies, right? So for example, if we consider, there are different RF devices that we make using semiconductor based on technology, based on the node, based on the power, based on the frequency of operation, and of course based on the application. So there are different there are different types of technologies. One, compound semiconductor, CMOS, sensors, and whatnot. So on the other hand, it also goes the other way, that there are a lot of basic electromagnetic concepts and RF concepts that are used in semiconductor to build the equipment. So for example, if we look at actually that goes a long way. If you It starts right from the designing part, where we kind of use basic RF concepts to uh, you know uh, uh, design the circuits, and understand that there are different tools that are required. So there have to be different models which need a lot of RF basic understanding. Based on those models, then you would design and then bring about the complete. So that is where also we need RF, and then in fabrication also there are different devices that needs electromagnetic parts. So for example, if you kind of let us say there is a chamber where you have to heat it, induction heating needs to be done. But for that you need an RF frequency, and again you cannot directly heat the inductor, which is basically doing the induction heating. You will need a capacitor to match the impedance. So there are a lot of different things that come into picture. Then again, plasma comes into picture. For plasma chambers, you need RF. There is different. There are different applications using plasma. One, just cleaning. Then there is etching. So all those things come into picture. Again, RF has its role to play. Then again, when you go to characterization, you will need a different set of equipments to characterize RF devices. So then all the different instruments and equipments come into picture where you have to characterize the RF devices. So it's kind of it's just like different verticals or different enablers in the semiconductors, how they help each other to run the semiconductor industry. It's exactly like that. Just like RF, there are so many other like embedded systems and AI and things like that, which kind of run each other, right? So it is so RF and semiconductors is that this is how the RF and semiconductors kind of feed each other.
Yes. So, if you are explaining what is RF to a layman or people who are beginning in electronics, then how you will do that?
People in electronics.
Yeah.
Okay. Okay.
Yeah,
Okay. So
actually,
I'll just consider it. Yeah.
many beginners will also watch this podcast, so a little background for them.
So when we say RF, basically when we speak or when we see something, that is an information, right? And when we look at something, we know that there is a chair in there, or there is something in the front, so that gives us an information, right? But that is in the visual frequency, right? That's an optical frequency. And when you hear, there is a audio frequency. Right? So there is a whole spectrum of frequencies where data can be, transmitted and received. So where you can send information or receive information, right? So just like how we know, sound and light are a medium, there is a frequency range in between these two, which can be transmitted, can be received, and it can handle it. And that data can be digital or analog. So that way we know that we are uh, sending the data faster than audio, but it is slower than, or rather, it is not always slower than. But when you are radiating, let us say, it has exactly the speed of light. So but you cannot see it, right? So you are basically sending a light signal which you can't see. If I have to
Yes,
just put it in
yes.
put it visually.
Yeah, that's interesting. So, what are the some design challenges when integrating RF circuits on modern chip?
Right, right. So there are different challenges. See, one thing is that we might have seen there are different ICs that are available, or earlier in earlier times they were available, which were working in only in digital, right? So there was just zero and just one. So you knew what is zero and zero one, and anything in between was not a data, right?
Yes.
But when you go to analog, everything that you receive can be a data or can be a noise. So there is a first challenge is that to identify what is the data and what is noise. So that is the biggest challenge when you work in analog, or if not just RF actually. That is the first challenge. And but later on, when you go for, if the variation is even faster, then you need to sample the data. Okay. So sampling becomes a challenge when the variation in the signal is high. You need to sample the data, high data, so that you can kind of look at it. Then uh, make sense of it. But now when we are talking about R, the frequency has gone so up, increased that there are different sampling, there are different devices that can detect and process, but their frequency of sampling may not be enough, right? So we need to have further higher data range. And then even I think there are many technologies that are even coming now, which are kind of trying to make sense of RF data directly. Not even, so what we usually do in today's or even or at least till recently was you bound to it, and so that they can be they are sampleable, right? But now there are a few things coming into, in the market which have a different protocol, which are very high frequency. So I think in VLSI, you guys must be knowing about there is a protocol called GEST, right?
Yes.
So it kind of directly samples the RF. So the data rate is so high. So that is something, that is, sampling is one of the challenges. Other than that, I think there is one foremost important challenge that needs to be handled is noise. Because even if, even when you must have read about or rather worked on circuits or circuits analog and digital put together, you would see that there would be an inductor that will differentiate between the digital and analog. Right? So that is because you want to get rid of all the noises that are coming in from the other circuits, right? So that is a big challenge even in IC design. So you need to make sure that noise of the system is so low that whenever you are trying to detect an RF signal, it is noise prone. So that noise is one of the important things. Then again, there are different substrates because different applications will use different technology or different substrates. Right? So you need to, if you're working on different applications, depending on that, you may have to have, let us say, power supply part and then digital part and then RF part, right? But they may be working in different technologies, so you need to put them together. So that is a challenge. Then I think when you're working at different applications, let us say, in which there are different requirements. For example, power and frequency, there has to be a combination. Then let us say there is noise and frequency, there has to be a combination, or there has to be a trade-off. So it becomes very important to decide which technology you should go with. Yes. Only then you can give the right solution. So I think till recently there was something called multi-chip technology, where you can have different modules in different technologies and then you put together and then use it further. And again, I think further to that, there is another challenge which is parasitic, because in RF, as we all understand, capacitance and inductance are something very important. So when you have capacitor inductances, they will have their own effect at higher frequencies. And in fact, if the frequencies, the capacitor inductors have lower value, then they would have even further higher effect on the higher frequencies. So we may want to, keep the parasitics as low as possible. So when you are having bound, wire bounds or things like that, then the parasitics will come in. So you need to consider that. So these are few challenges that RF designing will have in IC.
Yeah, that was very insightful. So can you explain the importance of mixed signal design in today's semiconductors landscape?
Sure. So I think when ICs had come into existence, they were only digital and, where it was just digital to digital, and we didn't have any kind of, connection with the real world per se. Okay. After we have built different sensors and then different ICs, analog ICs. Now we know that there are so many different things that we can do with the ICs, connect directly to the real world. So there are different sensors that can sense different, real world values. May it be temperature, may it be pressure, may it be anything which later on gets converted to, you know, uh, analog voltages or some other parameters, which can then later be converted to digital. So now I think that is exactly where the mixed signal ICs came into existence. I think the importance of mixed signal is so big, so huge in this semiconductor industry that it is solving so many problems. Earlier analog ICs were different and digital ICs were different. So mixed signals have kind of, integrated both of them. Right? So, for example, we take ADCs and DACs, where analog and digital signals come together. And of course, when we're talking about RF further, then the complete RF chain, if we have to consider that, will come in one IC, where all the analog RF data is taken in first, and then it can directly be given to the backend. So I think mixed signals have greatly benefited us in this semiconductor journey.
So, how does semiconductors are supporting the emerging RF applications like 5G, radar, or satellite communications?
Right. So when we look at different, applications of RF, for example, maybe satellite communication or, defense applications, quantum applications for quantum technology applications. So every application will have a different requirement, and that will be extensive, right? For example, when we are looking at, let us say, quantum technology or some application in defense, that needs a wideband application. It needs wideband data reception. So in that case, you're going to need to have a very fast system that is going to, scan the complete band and then give you all the data that is required, and then it is going to make sense out of the data and then tell you what's going on, basically, right? So in that case, data acquisition and faster memory storage. So these two things become so important when you are trying to deal with so much data. Nowadays, there are so many applications that are working, that are dealing with so much of data, right? So when you have so much data, and then you have to quickly make sense out of it and then analyze it, right? So in that case, all the thing that is required for RF systems that play a large role, a very important role. So that's where fast data acquisition, as I was mentioning, that there is something called JESD, and then it uses different protocols like SERDES. And I think there is, again, in automotives, there is, for automotive radars, I think there is something called ADAS, right? Something like that. So all these are the backends that are going to, fulfill the requirements of, data acquisition at the backend from the RF data. So yeah, that way VLSI is going to play such a big role.
Yeah,
Right?
yeah. So let us now move towards the entrepreneurship angle of this podcast. So what inspired you to venture into semiconductor entrepreneurship, especially in a deep tech like RF and semiconductors?
Yeah. So I mentioned about my RF journey, right? So I think it was fixed in my mind that I want to work in RF. But when I joined sales in ISC, there when I was working with things, I kind of learned so many things and realized that is the basis of how transistors work. And actually, I was kind of I could relate it to it. It may sound a little naive, but when I was doing growth in gallium nitride, right? There's something called a recipe. You basically write a recipe and then you just run it. So it kind of related. I mean, it is related. I could correlate it with cooking.
Yeah.
Cooking is how cooking is very interesting. You have a chamber in semiconductors. You have a chamber, and then things happen at particular temperature, at a particular pressure, and particular flow. That kind of is very interesting. So that's how I was very fascinated with that, and I stick to it. And then I started learning more about how equipments are working and how the technology came into existence. So that was very interesting.
Yes.
So I thought that is how I should stick to it, and I kept learning further. And after so many, after 4 years, about 3 years, when uh, uh, after making so many RF devices, RF products, I thought, we can do something in our own, indigenous development. Some indigenous development can be made because we have been seeing that there are a lot of different companies that are coming into Indian different plants are coming in India, which have kind of 1,000 CR and 10,000 CR and whatnot, right? So all the way, it's my personal belief that when you work at such a expensive scenario, the equipments are imported, right? So here we need to kind of step up and start trying to build things indigenously, which is very important in today's day and time.
Right.
Because the reason being, even though we are saying that we want to become Atmanirbhar, there is an element which is still keeping us nirbhar, right? And we need to move ahead of that. So equipment, for that matter, is one of the things that eventually, if not today, eventually we are going to have to overcome. So that is one of the things that I think must be chased. And we should have complete indigenization in whichever way we can. And also, which not many people mention about it, but other than design, other than fabrication, other than packaging, characterization is something that is very important, and even that is not much explored. So I think characterization is something that we are also trying to work on, because at least as far as RF is concerned. Right? So that's how it kind of got me so interested, and it just opened the floodgates to me, thinking there are so many opportunities. Right? So that's how I stick to RF and semiconductors.
So, what are the key roadblocks a hardware startup faces compared to a software startup?
Right. So that's a very good question, actually. When you start a hardware startup, one thing that I have observed is if you are entering into a sector which is already existing. For example, let's just take RF products. So RF products are not new, right? RF products already exist. But the RF products that already exist are either by the West or by China, right? So it is important that you understand where the market is and what value indigenization holds. So that becomes a challenge while starting, saying that the products already exist and they are even inexpensive. Then how are you going to compete? So that is one challenge that one might face while starting the startup. So there are different ways to penetrate. One has to understand, different uh, nuances, some of the products that will stand out, things like that. So that is one challenge. Second challenge is, of course, money, because when you are working in software, you have one software, you have one laptop, you have one software. You can make as many mistakes as you want, right? Of course, if that liberty is given to you. Okay, but in hardware, you're going to spend money in making the hardware once you know that it is going to, once you think that it is going to work. But it never happens like that, because hardware can be analog, can be digital, even for digital. There are so many variants. There are so many different variants, which can just ruin everything. So you have to have a very thought thing, but nonetheless, you have to kind of take it by default that you're going to have couple of iterations. So it's that just says that it's kindness capital, and this is just RF. When it comes to semiconductor, it's a whole lot of different story, right? Because there's so much money involved, and at least in fabrication. But of course, even if you are going to have softwares, even they are not, that inexpensive, right? So, but of course, there are alternatives one can find about running those. So yeah, money is one thing, and as I was mentioning, money is one thing, and one more thing that I find that is challenging is you don't usually get uh, manpower for that. There is, it is. We have to accept this, that there is a trend which has been going on for quite a while, which is good trend, that people want to go to softwares and want to work in softwares. But eventually, what has happened is that hardware kind of needs more hard work.
Right.
More hard work in the sense they should be ready to do that physical work and fail and then do it again. In that sense, so what I have seen is that the manpower for doing that is kind of lacking. So it is sometimes is a difficult job to get people who are really interested in hardware and want to uh, uh, spend time learning things and then get it. So yeah, employment in hardware is
Yeah. So, what advice would you like to give to young engineers who want to build something into chip design space?
chip design space. Yes. So I think it is important that you uh, start with something small. Okay. In the sense, if you're doing things alone, in that case, there are a lot of free softwares available. So, what is important as a first step is to understand the concepts and do things on your own and see if they work. So, one need not think about, 45 nanometers and 90 nanometers and 10 nanometers, or, nothing like that. One can just start with something in micron. Even I would say even in mm, doesn't matter. there are so many other so many softwares that are available where you can build things, right? And is as basic understanding. So you can, and then you can slowly increase the complexity, and then eventually when you are at a stage you understand things better, then probably you can. There are further to that there are different courses that are available, and using those courses you can get more insights into different uh, you know uh, uh, technologies. Then I believe communities like yours, or there are so many other communities. There will be a lot of knowledge sharing. Those things will happen. So I think and I think they should start becoming the part of the ecosystem and listen to what people are saying in the ecosystem, because it is very important that um, even though they are starting now, it is important that they try and understand what is being said in these seminars or in these different activities and things. So because why? Because they are coming from another end. Right? They are coming from the user's perspective. So you are going to you can be a potential candidate for them to be able to do those things what they want, right? So you understand what they're speaking. They're coming from perspective of an employer, from a designer, from a perspective of a startup owner, right? So it will also give you so many perspective on what are the gaps in the industry that you can fulfill. So for that matter, there are so many gaps in semiconductor industries. Just one startup can fill a big gap, right?
Right.
And also, when you're starting a startup, try to build a startup community where you feed each, or rather support each other. That will so for example, just one example that one of the experiences that I can share, which will kind of correlate here, is that when when the company is small like mine, so we were trying to get a project, and it needed a whole lot of different aspects into it, right? But I was not able to get the project. But later on, when I communicated and networked with different startups, and we came together, and then three startups together actually made the we got the project, and everyone benefited from it, right? So it was a good way to support each other, and it's a win-win situation. So think in those terms, because that is very essential at this point. And when you're small, you don't compete, you basically work together.
Yeah. So, so what is the one myth you would like uh, about building hardware startups that you would like to bust?
Yeah, I think there is a big myth that people think that hardware doesn't give money. It's
Yeah.
not the case at all. I think, especially in this day and age, hardware is going to give you more money, because there is very less competition. So your demand is going to be more. So one has to think in that direction. And yes, there is a hard work. Yes, there is going to be a lot of repetitions. Yes, it is going to need a lot of money, but the returns are going to be multifold. So one has to kind of think beyond the challenges.
Yeah. So, would you like to throw some light on open source tools which are coming for semiconductors, VLSI, like things? Analog also,
Yeah, yeah, sure.
analog VLSI.
Right. Sure. I think that's a great question. I would also like to just Okay, I'll come to that later. So there is one software that I came across, or rather a platform that I came across, I think last year. And that time we worked on, that time we were trying to build or, um, gather people who would be interested in making or, in chip design. And that is because we kind of came across a platform called eFabless that was making different, that was offering to fabricate the designs that we were making. Right? So I think it was such a great opportunity. So since my interest was in analog, I started, exploring it. So that is one platform that I actually got interested in and explored a little bit. So I believe as a practice, there are different softwares that come under that platform, which you can basically uh, kind of use in the, there was one called Scan and there was one called K layout, and I think of course there are different many others. So using Schem, I think I could basically use lumped capacitor and to design that in it, and then using those we made a RF filter which was basically for a particular foundry you know what do you call it PDK. It was very so it was a great experience. We could actually make capacitors in micrometers and indicators in micrometers and basically
Yes.
put them together and build filters. It was perfectly fine. Right. So that was one, and then I think we also made a low noise amplifier. So that was also great learning from there. You could basically do design a low noise amplifier with all the parameters, uh, simulated and see if it works fine or not. Then K layout, you can see K layout was for the layout, and there were so many different devices that you could import it and build the layout. So I think that was one of the freewares that I used. If you want to start with basic RF understanding for ideal capacitors, ideal components, there is a software called QUCS. It's freely available. You could you download it and just do some basic understanding of RF and RF circuits, may it be amplifier, may it be filter, may it be anything. You could also include transmission lines into it, because one point I missed when I said, what are the challenges in RF in VLSI is the interconnect. Because when you have, actually it was a part of the point when I said there are parasitics involved, so that the parasitics are involved also because of interconnect. So you have to have a very intelligently designed layout where you get what you want, but you also have different least path, least resistance paths are covered, and you can have minimum interconnects, right? So interconnects are something again that are important. So in the layout you can introduce interconnects and then do the simulation, and then you can understand what effect they are making in your simulation outputs. So that is there. Other than that, I think, of course, evaluation versions are available. You can try them out, but they don't usually last longer. Yeah, I think these are few softwares that I can develop.
Would you like to compare the open source and paid EDA tools which are there, their limitations and advantages between the both?
Yes, right. So I think I had asked these questions in one of the eFabless meetings that in softwares, in commercial softwares, of course, it has an upper hand in some cases where you can, you have a particular, you can take any library which is, for example, if you take cadence, if you take ADS is one of the commercial softwares, which is one design system like eShide, where you can make RFPs. So there are so many compatible libraries that are available. You can just import it, start using it. PDKs are available, easily available.
Yes.
That is one advantage of commercial software. You're saying something?
No.
So that is one advantage of commercial softwares. And second thing is you get, of course, I think even eFabless broke this myth that open source softwares don't give support. They have amazing support and things like that. So
Like,
that's uh,
yes, I want to add that eFabless have changed to chipfoundry.io now. So that was,
okay.
yeah.
Yeah. Chipfoundry.io, right? And one thing that I realized is in these softwares, I'm not sure if that happens in Cadence, but I think there is a compatibility of Cadence as well as ADS. So that problem may not be there. But what I observed is when you work in open source, I realized that there is no EM simulation. There is no electromagnetic simulation available. So that kind of gives a space or gives some space for doubt if things are going to work in electromagnetic compatibility mode or if there are going to be electromagnetic interferences. So that I'm not sure. So even if you take different PDKs, which will have different metal layers and with some dielectric in between, if those dielectrics are that spacing dielectrics are very less, in that case, you are not sure if the interferences are going to happen or not. And although you may take care of all the protocols, but as we see, these things, there are so many unprecedented things that come into picture, and eventually spending a lot of money into the fabrication, and then you might find it not working. So that's a big risk.
Yeah,
So electromagnetic stimulation is essential.
yeah. So where do you see the convergence of RF and semiconductor in next 5 to 10 years?
Yeah, I think so many applications that are actually it's actually in place, but if I have to talk about in context with India,
Yes.
excuse me, if I have to talk about it in context with India, I think um there is still some exposure the industry or the ecosystem needs in terms of how RF and VLSI or semiconductors can come together and go ahead. It I, from how I understand, that gap is still existing, so it needs some work. That's what I think. It hasn't, because even if you take different plants or different bigger companies that are working in semiconductors nowadays, they are in either memory or in CMOS, different types of CMOS. These things. Uh, if uh, if that is to my limited knowledge. If anyone can correct me, I will be pained. The It's especially working in memory or different CMOS, but I don't see anyone giving more attention to the RF part yet. So on the contrary, that is one big opportunity for newcomers.
Yes. So
So,
yeah. So it was a very interesting podcast. So thank you for joining our podcast. We look forward to more insightful sessions like this in future.
uh,
Yeah.
yes, thank you so much for inviting me, and I was I'm more than happy to share anything further as well.
Yeah. So our next yes. Any questions? Okay.
Actually, I have one question. Like you told, if you go for startup and
Correct.
how to make sure that market will, whatever we are doing, that will boom in market or will make a revenue as fast as possible. Like, hello.
I think
Okay.
I think internet.